Christian.
Hi, teacher.
Do you like baseball?
Kinda.
You like soccer better, but you like baseball. You told me before.
Mm-hmm.
So today we're going to solve a word problem, and we are going to learn a little bit about portions and ratios.
What's a ratio?
A ratio is an expression that explains quantity. So let's take a look at our word problem. Mark and Dave collect baseball cards. Together, they have collected 60 baseball cards. Okay, so here's our problem. If Dave has twice as many cards as Mark, how many cards does each of them have? It's also asking us, what is the ratio of Dave's cards to Mark's? So let's solve the first question. It's asking us if they have 60 cards together and Dave has twice as many cards, how much will each have? So let's first get our 60 cards laid out on the table. Oops. Maybe you can help me out with that. We're going to try and keep the cards in rows, and we'll get them all laid out on the table here. Right side up as well. So, I'll get this done as quick as possible. There's some nice cards in here, don't you think?
Yes.
You used to play Little League, right? You were really good. I remember you told me you were on the Colorado Rockies. Awesome team. It's got quite a few cards here. We're not going to run out of space. So I have already gone ahead and counted out 60, so I know that we have 60 cards here. I'm just going to try and get them all displayed out here just so that we can get a clear idea of our problem. Okay, so now we have 60 cards. The next thing we're going to need to do to help find out how many each person has is we're going to divide these cards into 3 groups. And in each of the group, I want to have an equal number of cards. So if we have 60 cards and we're going to have 3 groups, how many cards are going to go in each group?
20.
That's a simple problem, right? We've got 60 and we're going to divide it by 3. And we get 20. So let's put 20 in each group. We'll divide the table up. And what we can do, we've got 5 rows going down. We can do 4 columns. So we'll do 4 columns and 5 rows in each section. Just kind of separate them on this table. It's barely going to fit, but I'm pretty sure we can get it to fit here. Okay, perfect. So I've got a section here, I've got a section there. You can even draw lines down the table here. So I've got 4 rows, 5 rows, 4 columns here, 5 rows for here, and 5 rows for there. So we've got 20, 20, and 20. So if Dave has twice as many cards as Mark, I'm going to give Dave 2 of the sections. I'm going to give Mark 1 of the sections, right? And how many cards are in 2 of the sections?
Each one has 20, so 40.
Each one has 20, so that's 40 total. Very nice. And then I've got 20 over here. And like we've said before, 40 plus 20 equals
60.
60, our total amount of cards. Very nice. So, if we're saying that Dave has 40 cards and Mark has 20 cards, how will we figure out the ratio? We would simply do that by saying, okay, Dave has 40 cards and Mark has 20 cards. And when we're talking about ratios, we use this symbol. Two little dots. So we've got the ratio of 40 to 20. So our ratio in this case is 40 to 20. So let's move these cards out of the way and get some paper out and solve this problem a different way.
Let me pick up the cards.
Yeah, you can help me pick the cards, thank you. All right, put those all over there. Put them in a stack. You can actually just kind of move them, oops, move them out of the way there. And what we're gonna do now, get out our pencils and our papers. And I'm gonna take this paper. I think we're good. We're good. You can just set those right over there. Okay? We're gonna take our paper, and just like we had our table of cards divided into thirds, we are going to divide our paper into thirds, just like this. Just like if we were going to put this paper into an envelope, we'd fold it into thirds. And then we're going to open it up right, just like that. Now, once we've done that, just to help us be super clear of our section, we can draw a little dotted line or a little solid line, perfect. Little solid line, however you think was best to help you know where your sections are. So we've got 1, 2, 3 sections. Perfect. So now, instead of baseball cards, we're going to either use rectangles or tallies, whichever you prefer. It's a little quicker to use tallies. So let's use tallies. So we're going to tally mark an equal number in each section, just like we did with the baseball cards. And we already know that there are 20 in each section, so let's put our tallies in there. All right, perfect. So, oops, I need to do one more set here of 5. So now I've got 20 in this section, 20 here, and 20 here. What number does each of the tallies represent?
1.
One baseball card, right? So if we were counting how many marbles Mark had compared to Dave, could we use tally marks for that too? It'd be it'd be the same, right?
Yes.
It's not much different than if we had marbles that we're counting, or baseball cards that we're counting, or sticks of gum, or pencils. You could be counting any type of object, and we could still be using our tally marks, or circles, or rectangles, however you want to count your objects on the paper. And we're going to solve it the same way. So if Dave has twice as many baseball cards, which is what these tallies are representing, we're going to give him 2 of the sections, right?
Yes.
So we're going to circle those, put Dave's name right below those. And we're going to circle the one section, put Mark's name right below that. And now that we've solved that, we know that Dave has 40 cards, Mark has 20 cards. But looking at these sections, I see there's 2 sections to 1 section. So that's another way we could do our ratio, right?
Yes.
We've got 2 to 1. So we can say that as 40 to 20, or we can say that as 2 to 1. So you did a great job. That looks perfect. All right, let's think of some other ways we can solve this problem. Let's really get into our algebraic equation, because I know you're really great at algebra. So we'll set that aside, and you can get out your math notebook. Okay, so What's a way we can write this equation out as an algebraic equation? We're going to write the problem out. One way we could do it, we know that Dave has twice as many cards as Mark, so Dave would equal 2x. Mark would equal x. X being the amount of cards, right?
Mhm.
Dave has twice as many cards as Mark has cards. Another way that we could solve this problem is we could say 3x equals 60. So we would say, what times 3 equals 60? Do you know that off the top of your head?
No.
3 times something equals 60.
No, I don't.
3 times 20 equals 60. So there again, we're going to have our number 20. We're going to write that down 3 times, and then we're going to know that Dave is 20 plus 20 equals 40 cards. So what does this symbol mean, 2x? What does that mean?
40?
It means 40, so it's meaning 2 times the number of cards, right? 2x equals 2 times the number of cards. And if x equals 20, 2 times x equals 40, right?
Yes.
So if we read our problem again, Mark and Dave collect baseball cards together. They have collected 60 baseball cards. If Dave has twice the amount of cards as Mark, how many cards does each have? Our answer was, Dave has how many?
40?
For Dave. And Mark has how many?
20?
20 for Mark. So we had the number 40 and we had the number 20. And our ratio, we figured that out to be what?
40 to 20?
40 to 20. Now how would you think we would simplify that? If we know that our number is 40 to 20, how would we simplify that ratio?
Could we put 20 into 40 2 times?
Very good. Just like a fraction, right? So we find our common denominator between the two, and we know that 20 goes into 40 2 times, and it goes into itself 1 time. So another way we could say the ratio of Dave's cards to Mark's cards is we could say the ratio is 2 to 1. So what do you think about ratios?
They're kind of hard to solve.
You think they're kind of hard?
Yes.
You think you're starting to understand ratios?
Yes.
Seems to me like you are. Okay. So let's think of some other questions we can ask ourselves about this lesson. Can you tell me the definition of a ratio now after we've just done that?
The ratio is between the first number and the second number?
Between the first number and the second number, so we can say that it's an expression that explains the quantity. That's what a ratio is.
Okay.
Okay, thanks for being a great student, and I am going to check this clock because I hope it's been 13 minutes. Okay, I think we got it. How'd we do?